This is a video from section 7.4. The directions say to evaluate the integral. We're going to start off with this question here. We'll call this example 1. Suppose we have the integral of square root of 1 plus the square root of x divided by x dx. And so I'm going to let u equal the square root of x. So u squared is x, and dx is 2u du. And so this is the integral of the square root of 1 plus u divided by u squared times 2u du. And if I go to simplify this, we get twice the integral of square root of 1 plus u divided by u du. So I'm going to make another substitution. I'm going to let v be the square root of 1 plus u. It's easier if you don't deal with radicals. And so if I square both sides, I get 1 plus u equals v squared. So 2v dv is du. Now, from the second line, I can say that u is v squared minus 1. So this is 2 times the integral. I'm going to replace square root of 1 plus u with v. I'm going to divide by v squared minus 1. And du becomes 2v dv. So 2 times 2 is 4, so I'm going to pull the 4 out in front and multiply by the integral of v squared over v squared minus 1 dv. And from here, this is 4 times the integral. So I'm going to take v squared over v squared minus 1. I'm going to subtract 1 and add 1. It's like adding 0. Okay? And so this is just a rewrite of the previous line. Why? Because I want to be able to split off the fraction and be able to cancel the denominator in the first fraction, basically. And I'll show you what I mean. So what we have is v squared minus 1 over v squared minus 1, and I'm going to add 1 over v squared minus 1 dv. Notice how the first fraction reduces nicely to 1, and I want it to reduce nicely by design. And if I factor the denominator in the second fraction, I get 1 over v plus 1 times v minus 1. To integrate the second fraction, we need partial fraction decomposition. So 1 over v plus 1 times v minus 1 is going to be split off into a over v plus 1 plus b divided by v minus 1. So I'm going to multiply through by the LCD, and the LCD is v plus 1 times v minus 1. So 1 is a times v minus 1 plus b times v plus 1. Distribute the a, distribute the b. So 1 is av minus a plus bv plus b. So I'm going to collect the terms that contain the v, and I'm going to factor out the v at the same time. So I get a plus b multiplied by v minus a plus b. Now, what that tells me is that a plus b has to add up to 0 because on the left-hand side of the equation, there's no v's involved, right? And so here, a plus b is forced to be 0. And negative a plus b equals 1. And if you remember, if B equals C and D equals E, if I add up the left side, I get B plus D. And that's the same as adding up the right side. So I'm just going to basically do that over here. So 2B equals 1, and that implies B is a half. And if B is a half, that tells me A is negative a half. And I'm in business. And so the integral of, got to go back here. Okay, so we're going to go 4 times the integral of v squared over v squared minus 1 dv is going to be 4 times the integral of 1. Okay, and then we have to come back here. Now, a is negative a half, so it's minus a half times 1 over v plus 1, and b is positive a half. So we're got 1/2 of 1 over v minus 1, this whole thing dv. And so this is 4 times. We're going to get v minus 1/2 natural log of v plus 1 plus 1/2 natural log of v minus 1 plus c. Okay? But remember that v, we have to go back here somewhere. That's the square root of 1 plus u. Remember that v is the square root of 1 plus u. And so this is going to be equal to 4 times the square root of 1 plus u minus 1/2 natural log. Now, I'm going to just put the 1 first if you don't mind. So I'm going to take 1 plus the square root of 1 plus u plus 1/2 natural log of the square root of 1 plus u minus 1 plus c. But u is the square root of x. So this is going to be 4 times the quantity, and we get the square root of 1 plus the square root of x minus 1/2 natural log of 1 plus the square root of 1 plus the square root of x plus 1/2 natural log of, and then I'm going to get the square root of 1 plus the square root of x minus 1 plus c. And that right there is how you do example 1. If we take a look at example 2, there's a really slick solution to this type of problem. Suppose we had 1 over 1 plus e to the x dx. You can solve this by use substitution, by partial fraction, but I'm going to teach you another way. Suppose I add e to the x and subtract e to the x to the numerator. So I didn't write anything wrong because all I did was add 0. Okay? And I'm going to split off the fraction. So this is the integral of 1 plus e to the x over 1 plus e to the x minus e to the x over 1 plus e to the x dx. So this is the integral of 1 minus e to the x over e to the x plus 1 dx. So the answer here is x minus natural log of e to the x plus 1 plus c. And you're done immediately. So this is a really, really slick solution. Now, could you do this problem by partial fraction decomposition? Yes, you can. Works. You would just let u equal e to the x and then solve for x and then go accordingly. Suppose I give you this one. suppose I had 1 over, this will be example 3, by the way. So let's write that down. Suppose we have the integral of 1 over x squared plus x root x dx. So I'm going to let u be the square root of x. U squared is x, right? I want to get rid of that radical. And then 2u du is the same as dx. Now, I'm going to get 1 over, if I square this, in other words, if I square each side, I'm going to get u to the 4th. And remember that x is u squared, and I'm going to multiply by u. And then the numerator is 2u du. Just like this. So what I'm going to do here is I'm going to factor out, in the denominator, I'm going to factor out a u cubed. And then I get u plus 1. And in the numerator, I still have 2u there. Okay? Now, what this reduces to is the integral of 2 over u squared times u plus 1 du. So it's classic partial fraction decomposition. So I'm going to take 2 over u squared times u plus 1. Now, this is a over u plus b over u squared. So this is the equivalent of writing au plus b over u squared, by the way, okay? Plus c over u plus 1. So when you have a repeated linear factor, you can break it up this way. I'll talk a little bit more about that at the end of this example. Now, the LCD is u squared times u plus 1. So 2 is au times u plus 1 plus b times u plus 1 plus cu squared. And so 2 is au squared plus au plus bu plus b plus cu squared. And so 2 is a plus c times u squared plus a plus b times u plus b. Yep. Now, what this says is a plus c is forced to be 0, and same with a plus b. And b has to be 2. But if b is 2, a is negative 2. And if a is negative 2, that forces c to be 2. So this is what we need, okay? So I'm just using these two equations to get a, b, and c. Well, yeah, b is already given, and I need the other two equations to get a and c. So I get the integral of 2 over u squared times u plus 1 du. I'm going to get the integral of negative 2 over u plus 2 over u squared plus 2 over u plus 1 du. And so this is negative 2 natural log of the absolute value of u minus 2 over u plus 2 natural log of u plus 1 plus c. But remember that u all the way back there was the square root of x. And so this is going to be negative 2 natural log of the square root of x minus 2 over root x, okay, plus 2 natural log of the square root of x plus 1, right? And again, square root of x is in absolute values, same with the square root of x plus 1, plus c. And I'm going to leave it here, and once again, I'm going to leave it to your instructor to instruct how far they want you to simplify. Now, here's a question, right? So we had 2 over u squared times u plus 1 du. Yeah, there was a quadratic in the bottom, and so I could have very well have done this. And so this is my go-to. So usually when you have a quadratic, it reduces to a linear on top, right? And then if you have u plus 1, which is linear, you put a constant on top. But if you notice over here, over this way, I wrote a over u plus b over u squared. But I want you to watch what this reduces to. So we get 2 over u squared times u plus 1. I get au divided by u squared plus b over u squared plus a over u plus 1, right? And so therefore, 2 over u squared times u plus 1 is a over u plus b over u squared plus c over u plus 1. So it basically, you can do that generally speaking. So in other words, I could make the same argument or a similar argument if I had, I'm going to put a note here. So if I had 2 over, let's say, u plus 1 to the second times u plus 4, I would have done it this way. So instead of a u in the denominator, I have a u plus 1. And then instead of u squared in the denominator, I'm going to have u plus 1 squared in the denominator. So I have a over u plus 1 plus b over u plus 1 squared, and then I have my c over u plus 4. So that's how I would break it apart using partial fraction decomposition. So I could make this a similar argument. But notice we just basically took this au plus b over u squared and split off the fraction. And that'll conclude this video for section 7.4, and we worked over 3 examples in the partial fraction decomposition. Thank you.